Hello everyone, thank you for joining. I'm your host today, Casey. I'm a product consultant for Bentley for our civil and bridge product. So together with me, we have our bridge expert, Eugene Lee, who is a senior application engineer for the bridge and tunnel product of Bentley. So yeah, before I get started, some of you may have seen this image while waiting for our webinar to start. So this bridge is actually a shade-side bridge in Abu Dhabi, which is designed by High Point Randall, a consultant in UK. So the design of this bridge is using OpenBridge, which is the backbone analysis software of OpenBridge Designer, which you'll be hearing today. So this bridge, I think it was designed about at least 15 years ago. And you may wonder, 15 years ago, we are able to design such a bridge, but why do we have a new product today? Um, why we have this OpenBridge Designer, which is a suite of software that includes OpenBridge, is because the world of design has become more challenging, and the client would require the design quicker and quicker, and changes is more frequent than before. So that's why we have a new suite of software which is called OpenBridge Designer that includes OpenBridge. So today's agenda, Eugene will be presenting about the OpenBridge interface and what is physical bridge modeling. He also talked about the interoperability between the physical bridge model and the analytical interface. He'll introduce to you the analysis tool as well, mainly focused on RM Bridge. And then he'll talk about the production of 2D drawings from a 3D model. And lastly, he'll be talking about the deliverables, which is generating the documents required for the bridge project. And finally, we'll do a Q&A. So before we start, I'd like to introduce to you what is Virtuosity. So Bentley, in continuous support to support the bridge community, has developed a special commercial offering comprising of affordable and flexible software subscription bundle with customized training. So Virtuosity is Bentley's e-commerce platform that provides an easy way for you to purchase our software accompanied by the keys. So this keys is like a token which you can redeem for our expert service in the form of either mentoring or customized training. So all the latest version of OpenBridge Designer are available at virtuosity.com. So for every license purchase, a product expert is assigned to your team within a day or so. The product expert work closely with your designer to understand your team skill, project needs to customize the training. So this expert come with a rich experience working on a similar project. Yeah, including our presenter today, Mr. Eugene. You have the complete flexibility to choose or renew the license for the next 12 months or even add more keys as your need arise for the training or any consultation from us. So Virtuosity, like any of our e-commerce platform, you can just simply add the products you want to buy into cart, make your payment, and within 24 hours, your license will be delivered to you. And then you are assigned a product expert who will work with you on the initial software setup and training. So the advantage of this offering is within a week you can be equipped with the fundamental skills and your design work can be up and running already. So this initiative provide you with a quick and easy process to access the right solution, our knowledge base and training. So yeah, that is the background of Virtuosity. So before we start the session, I'll have three poll questions which I need you to answer so that it can help Eugene in his presentation. So the first question is, are you currently doing any bridge design project? Okay, I think that's about it. I'll close the current question. The next question is, if you are making a 3D model for your bridge project, which are the products that you are currently using? Okay, thank you for your answer. And yeah, I hope after you see today's presentation, you may change your mind. The last poll question is, which structural analysis software do you use for your current bridge projects? Okay, thank you so much for your feedback. So, yeah, without further delay the time, so I would like to hand over the session to Eugene, who will talk to you about the um, OpenBridge Designer product, which, yeah, you'll be hearing a lot today.
Okay, thanks, Casey.
You're welcome.
And then, hello, everyone. Thank you for joining to this webinar. My name is Eugene, and I'm working for bridge and tunnel product in Bentley Systems. And my background is a structural engineer for bridge analysis and design. Today, I'm going to explain how to create physical bridge models and 2D drawing generation from 3D model, and how interoperability with the analytical tool in OpenBridge Designer. Also, I will give you what feature will be updated to the new OpenBridge modeler. OpenBridge Designer specializing tool for the bridge engineers, and it is supporting the engineer to the bridge design from concept to reality modeling. It allows you can use physical bridge model and analytical design tool both. GINT is used to geotechnical modeling, and generated component will supporting the bridge engineer to do computational or parametric modeling. And ProConcrete will be used to place the lever into the model. Luminarity will be used to simulate reality modeling to help the engineer understanding operating condition. And RM and LibBridge will use to conduct bridge analysis and design. OpenBridge Designer enables you to perform bridge design using two workflows. When BIM workflow is selected, the engineer can proceed design by BIM process. Standard alone allow you can ignore the BIM workflow and can design bridge, use each of the feature into the OpenBridge Designer. Also, you can generate analytical model from physical model automatically. I'm going to explain how to create new file for the modeling on OpenBridge Designer, and select the procedure and create a group name, and select OpenBridge model, and move to new file to create a new bridge model. Select the CD file and define the file path and name to save this model. The CD file that has information like a design unit, category of line, text style, and label. And an empty model file is created. Physical bridge model on OpenBridge will be based on load or rail alignment, but sometimes civil engineer doesn't give the alignment to structural engineer due to several reasons. That's why I usually like to show you how to create the alignment object. And move to Civil tab and select the line on horizontal and specify starting point, length and direction of the line. And you can modify the length and direction anytime. And place the curve end of the line to define the arc radius and length. And I will combine the line and curve using complex geometry. The next step is generating particle alignment that be based on horizontal alignment. So select Open Profile on vertical, then select Complex Curve, and pick the second view to create a particle alignment. And define the starting elevation using data point keying, and create a line for vertical alignment. And set active profile, then you can see two curves for the alignment. Even if the load alignment is created by another company product, OpenBridge can be imported using various file extension. Also, load alignment was created in OpenBridge Designer. This file can be used as a reference file for the bridge model. And define the feature that will be engaged to the line color and type. And move to Attach to attach terrain model as a reference drawing. Once the load element has been determined, the bridge type and bridge location should be determined. Go to Add Bridge to define bridge name and type. In meantime, OpenBridge support deck with concrete and steel girder, RC slab, CIP concrete box, segment box, and steel tube bridge will be updated in the next release. The next release you can see today's. And assign the bridge name to the load alignment. And specify the bridge location through support line definition. And type design number of support. Select a starting and end point with a bridge skew angle. The support line can be copied in Excel and pasted to OpenBridge. Also, you can modify it anytime. Before I explain how to place segment, I want to let you know how to define balanced or unbalanced segment lengths using vertical bar on your keyboard. We will define pure segment lengths using colon because the analytical tool OpenBridge should know center of supporting point. We need to know how to create and address the custom template before create a physical bridge model. So I'm going to explain it in this slide. and move to library and select deck. And add a category for your account or project. And select add a template and define template name. And place the line. But it doesn't need to create it with the correct dimension. Also, you can attach the 2D profile as a reference that be created by the other CAD tool and copy and paste the profile to the working point. And import the template to the library. And we need a minimum 3 variables for deck width, thickness, and ship elevation. So select P1 and select horizontal and slope, and specify parent point and variable for right deck width and slope. And verify the movement due to the variables. And pick the P2 and select horizontal and offset to specify deck width and thickness. And specify variable for deck thickness. And move to P3 and select the offset only for deck thickness. Pick the variable and verify expected movement by the variables. Change the deck width and slope. And also you can specify negative slope also and change the deck thickness. And define the constraint and variable to P4 and P5, same as before method. For the left width and slope and deck thickness. Finally, verify the movement using defined variables. Next step, I'm going to place the bridge segment. Move to place segment to insert bridge segment on the load alignment and select the feature that predefined to DGen library and select a template that also define the variable for this bridge and define each number of segment and segment lengths. And place the segment to the support line. And OpenBridge model give us the warning message because you defined the segment lengths are longer than available spacing. So modify proposed segment lengths and place the remaining segment. And move to cross button to create a key segment and specify maximum segment length. Then OpenBridge is looking for less than spacing and will generate the key segment automatically. We are done. Place the bridge segment, but you want to define some variable along the bridge axis. For example, you want to define the bridge height. So I move to constraint, then select the variable name to specify the constraint. And this variable can copy it in Excel to OpenBridge model. And you are able to verify the constraint curve and variable value. Then OpenBridge will apply it to the model, and then the model is updated. Bridge engineer wanted to know each segment maximum length and weight to specify the pump traveler capacity. You can verify it through report button in OpenBridge. The next step is I'm going to explain how to place the substructure. There are two elevation definition methods in OpenBridge. You can define the elevation that is based on horizontal load alignment, while DTM that is laid with the terrain model. We have to activate the terrain model before place the substructure. Then putting top elevation will be defined that be based on terrain model. And move to place the abutment and select the proper picture and template. And check the desired options. And select the support line to place the abutment. And you can see the DTM. DTM meaning is digital terrain model. The template are based on parametric model, so the model backward height and width will adjust it automatically due to the option, even though the template real size doesn't purport to this bridge model. Basically, OpenBridge allows the engineer to define parametric structure element from the simple one to the most complex structure element that fully interact with bridge for the modeling, analysis, and detailing. You can see how to create a peer template in OpenBridge Designer. Define the template name and category to managing it. And you can see the peer component were separated by tabs. And specify cap geometry using the variable. It allows you can define edge shape, and you can also verify cap geometry through display mode. And modify column tab. Turn off the auto spacing to define the column location. And you can add the column, and you can define shape and size of each column individually. OpenBridge allows you enable to define several putting types, for example, isolated, combined putting, and drill shaft. You can also specify the shape and pile layout on putting, respectively. And also you can specify pile layout. Sometimes there is a special structure that needed to be modeled, architectural pier, or custom apartment. Those elements needed to be modeled using hand drafting tool with a little or non-existing parameterization. Therefore, any change in the structure force almost the total redraw of the structure. After modeling those custom structure, engineer needed to design, detail, and quantitate those elements. The use of a traditional tool in modeling forced the engineer to remodel the structure in his analytical solution and do manual calculation of a quantity. There is also a problem. The most engineers are not friendly with 3D model environment yet. However, the engineer and designer should respond quickly and flexible to design change. To do this, it is necessary to reflect in advance the scenario that can be changed to the modeling using variable and constraint. This is a pilot model for extra dojo bridge, but I would like to reuse this bridge, this model for the cable-stayed bridge also, so that I create this model with a functional component, and I used two ACS plane to generate this model, XZ plane for the pylon and XY plane for the pile cap, and I link the both ACS plane using 3D constraint because functional component allow me 2D constraint definition for the one ACS plane. You can change external radius, pylon height, and pylon better. And also you can change some pylon section dimension and cross girder. Finally, you enable to define putting size and number of file. And also you enable to place this model as a parametric cell into OpenBridge model. You can see the irregular solid element between coping and top of the column. And it didn't allow me to create a parametric irregular solid element through the functional component in MicroStation. That's why this inverted pier is created for the curved bridge using generic component in OpenBridge. This model allows you can change coping dimension and horizontal and longitudinal ship elevation on the pier. The irregular solid element will be adjusted by coping and top of the column dimension, and you can control the variable to modify file size and number of file. You can see the two barriers on the bridge model. One is the dark gray barrier that generated by OpenBridge, and the other one is green barrier that by component in OpenBridge model. And you enable cell if the bridge alignment is straight and there is no vertical curvature, but those conditions will be rare in the real world. This model allows you can control the gap between each barrier and precast barrier lengths. And I'm going to place the pier to this bridge model as the same before method. Move to place the pier and select proper picture and pier template. And select the desired support line to place the piers. And specify putting top elevation that will be based on digital terrain model. OpenBridge can place 3 types of bridge bearing, like a cube, cylinder, and cell. And I'm going to place the bearing using cell type and select cell template and define the center of bearing and horizontal location from center of load alignment. And specify bearing seat dimensions. And select the support line to place the bearing using predefined information. Then abutment bearing seat elevation will adjust it automatically from the vertical load alignment elevation. I will place the other bearing using same as before method. During you have designing the bridge, you will be able to have new load element from load or rail designer. The pain point is we need to recreate the physical model, but OpenBridge doesn't need to do it. Because OpenBridge model allows you can change the bridge geometry automatically through the alignment function. Move to attach to attach the new load alignment as a reference drawing. And you can confirm fully change the alignment and move to alignment and select a new load alignment for moving the bridge modeling from old alignment. Then all geometry of this bridge will be changed automatically. Bridge plan and elevation. I'm done create a physical bridge model, but I have to verify the elevation of putting top because the real terrain model will not flat. Move to open profile model on civil tab and open profile for the vertical alignment. And select 3D cut button to producing 2D drawing that be based on 3D model. And change the exaggerate scale. and change the top of footing elevation. And pick the updated 3D cut, then the drawing will be updated. I'm going to explain how to define ship elevation using the reference drawing that was generated from OpenBridge Designer, and specify left and right boundary, and select a starting station and step spacing to producing 2D cut drawing, and verify the 2D cut drawing. You can confirm the superstructure didn't define any segment. And move to Attach To attach the super elevation drawing as a reference. And assign the super elevation using the Assign button. Select the super elevation. Then also can verify the data. We need a post step to assign the super elevation because my bridge segment work group did post construction states, and you can define the super elevation through the constraint function before you watch the slide. Then you can confirm the superstructure that was applied by super elevation. When you start OpenBridge with a standalone in OpenBridge Designer, OpenBridge allows you accelerate design speed through the bridge wizard. You can define all information related with bridge analysis and design. It will generate analysis report automatically, and you enable to modify it and update the bridge model anytime. Also, you can see several partial regions like cable arrangement, rail and structure interaction modeling in OpenBridge, and it will help you to create the model more easily. For rail bridge, OpenBridge provides a unique calculation engine that will simplify the given structure and apply to its several terrain at several speed. This process in several pace, where the bridge structure become more complex, will reduce the scope of terrain and speed. So the bridge in his complex structure can be analyzed using the worst terrain and his worst speed to get the maximum response expected of the bridge. This advanced function has been legacy used for high-speed train across Europe for checking existing bridge or new bridge on new track. The bridge type is floating suspended bridge, and it was a critical issue to apply the wave loading to the bridge. And this engineering consulting wanted to apply this loading in OpenBridge. OpenBridge offers advanced spring element called the hydrodynamic spring and viscous damping load for the hydrodynamic analysis. Hydrodynamic analysis has been used in feasible study on new bridge concept which is being investigated for crossing the 5 kilometer in the west coast in Norway. They contact Bentley Bridge team, and we enhanced it for the long span bridge deck construction to the ocean. We've always have been trying to hear the voice of bridge engineers. The construction sequence is defined in OpenBridge model. OpenBridge performed the analysis and design as per OpenBridge build order, allow also from the structure point of view, a simulation of a construction stage, taking into account the construction duration for every phase through for the analysis. And you can customize the calculation report using RMView. You enable to use your company logo, can select the input data, and customize the result diagram. And you can generate the report very output format. Finally, the full report will be updated just one click. And in this slide, I will not give you detail explain how to define the tandem profile, design load, and construction stage in OpenBridge because of the time constraint. So I'm going to focus on the design workflow only. The physical bridge model will send to OpenBridge to execute analysis and design and specify the desired design code and boundary condition for this bridge model, and verify material laying for each bridge component. And OpenBridge will execute and generating analytical model that be based on physical bridge model. And you can easily verify the element name that automatically named it. And initialize, create the analytical model data. And add the material name for the tandem profile. Then I will import the TCL file that are already predefined the analytical condition, like a load, tandem profile, and construction stage. TCL file is similar with some STD file of stat. And run analysis. OpenBridge is able to considering time-dependent nonlinear construction stage analysis, like a cliff and shrinkage, and also you enable to calculate wind pipetting analysis also. Then move to extract to create the XML file for a tendon or lever, and close the OpenBridge and go to OpenBridge model and update the physical model. Then OpenBridge model will generate a tandem profile that be based on analytical model. You can verify all of information regarding tendon for the build the bridge. You can verify not only tendon area, duct diameter, but also tendon stretching action. In this slide, I'm going to explain how to generate bridge report. OpenBridge allows you can generate bridge geometry report for survey and quantity report, including concrete volume for each segment and component, bearing and tendon also. Can check the quantity in a chart, and it can make the report several file extension without any data loss. For example, I'm going to generate this report as an Excel sheet. Just define the file name and file path. Then you can see generated report that are same format and chart. And the bridge engineer has to create a real coordinate report for the construction survey, but it is not easy to generate it at required time. We will be able to create the report anytime for the geometry report. Select desired geometry and define the boundary to generate this report, and set up the location and format to present the report. And you are able to see the result and verify each location for the report. OpenBridge allows you enable to produce 2D drawing using several ways. Dynamic view is the one to create 2D section drawing for the selected station. Select desired station and set up the drawing style. Then the drawing extracted from 3D model. Go to Setting button to set up the substructure drawing format and style. And select the substructure to generate a 2D drawing. And you can see the apartment drawing, plan, section, and pile layout. You can see how to place the parametric lever in OpenBridge and place the lever in column and footing through the like some window command button. You can define number of lever, lips price, and of shape also. And I'm going to place the footing. It's similar with the column lever placing. And I'm going to change the load alignment. And then bridge and lever modeling will update it that be based on bridge geometry. Those drawings are 2D drawing produced by OpenBridge model for the pilot project in LADOT. You can see the bridge plan view, pier general view, and lever detailing drawing. I usually like to show you more elaborate drawing generated by each engineer company, but please understand that I cannot show you it for the security reason. You can create the bridge model using bridge wizard, and it will help you reducing your design time. I'm going to attach two reference files for the alignment and terrain model. But you don't need to have the alignment. Then OpenBridge model will create a new alignment and select bridge wizard to generate the bridge model and give the bridge name and specify bridge type and pick the template for each component. And you can select alignment and straight station to place the bridge model. And also you can specify your desired material name and property for each component. And then it'll take less than 1 minute. And then you can see the create the bridge model through the widget. And you will be able to see new features into OpenBridge 2021 release 1 on today's. OpenBridge allow you enable to generate steel tube bridges. You can define the variable for each component, thickness, and girder height along the bridge axis. Also, you can define the bridge bearing up to the 3 on the each girders. You will be able to generate the quantity and geometry report also. You can place the steel diaphragm to the concrete girder bridge. You should use same library file as a steel for the diaphragm, and you must select the beam type as concrete to place it to the concrete girder bridge. At this moment, OpenBridge model supporting the frame type as bent plate diaphragm, inverted V, and X frame. And we updated foundation decorator to help you when you produce to the layout drawing. The decorator will generate automatically when you place the bridge component. OpenBridge model produce decorator for the footing, pile, inclined pile with direction arrow, drill shaft, and functional component also. And you can handle the view using the level manager or OpenBridge model explorer. And utilizing method is similar with the deck definition for the column variable, but you need to define the variable and constraint into the column template. And you can use variable and specify variation linear, parabolic transition along the column lengths. And we will update the helper resource to help learning OpenBridge Designer more easily. The content is split with each product in OpenBridge Designer. You will be able to access recorded video through the hyperlink in help resource, and you can get the help anytime from Bentley Technical Expert. Okay, now I will open the floor for Q&A.
Right. Thanks, Eugene, for the insightful presentation and some wonderful live demo from you as well. So I see there's some question from the floor. The first one, they're asking like, what is the bridge design standard available in OpenBridge Designer?
Okay, and then OpenBridge Designer allow you you can use the bridge standard like some Singapore standard and Euro code. and Eurocode and VS Code and Cynic code. Also, maybe you can use more than 21 standard in the globally.
Okay, thanks for that. The next question is, what are the bridge types which can be designed with using OpenBridge Designer?
At this moment, you enable to analysis and design through OpenBridge Designer, like some RC slab and concrete deck with a concrete girder and deck with a steel girder and segmented box bridge. And also, you enable to come over using a general component in OpenBridge mode in OpenBridge.
I guess is the suspension bridge type and cable stayed type already covered in OpenBridge Designer?
No.
Not.
Analytical function is enabled to covered by OpenBridge, but at this moment we do not supporting for physical bridge model for cable state and suspend bridge.
I see. Okay, so for the information of the audience, you can also use OpenBridge independently within OpenBridge Designer. So this bridge type, you may not be able to use the bridge workflow yet, but you can use OpenBridge independently to do the design. Is that right, Eugene?
Correct.
Okay.
Yeah, correct.
Okay, great. So I think the third one is more on the commercial side. This person is asking, where can I find this program, and can I get training from simple bridge until complex bridge? And in future that I design a bridge that I can't do, is there any chance to get consultation? Okay, I'll take this question, Eugene. So this offering which I mentioned earlier in the presentation, Virtuoso, it covers already both in terms of the simple training which you mentioned, which you can access to our Learn server. You take you step by step on how to build the simple typical bridges. And then also with a Virtuoso subscription, you will get consultation hours, which you can send in the type of bridge that you want to build, and then using the consultation hours, we'll do probably like a customized training to help you to build the bridge that you want. So how to get it is either you go straight to Virtuoso website to purchase, or otherwise you can reach out to me through my email. My email address is in the email link to this webinar, and yeah, we can discuss further on how to supply you with this OpenBridge Designer software. Yeah, I think that is about it for the questions. So before we end the session, I would like to thank again Eugene for the very detailed presentation on this OpenBridge Designer. And for the audience, thanks for coming. And before leaving, I would appreciate that you guys answer the survey questions before you exit this webinar interface. And we hope to see you again in the future Bridge webinars. Thank you so much.
Kevin, sorry, we have some more question.
Oh yeah.
And is it possible to interact OpenBridge with Plexus 3D? At this moment, we don't have interoperability between OpenBridge and Plexus, but already you watched some parametric 3D model like some pylon and pier, and then you enable to export it to DXF format, and then Plexus 3D can import the DXF file directly, and then you enable to analysis and design for the soil and structure interaction analysis.
Okay. Sorry, there's another one coming. This person is asking the link for Bentley training. So probably you can reach out to me through email. I'll see like if you have any existing license of Bentley with you, then probably from there I can advise you on how to get the training. Okay, so I guess there's no more questions. So yeah, so in case that you have something to ask technically about OpenBridge Designer, please reach out to me first, and I'll link you up with Eugene so that we can yeah, try our best to fulfill what you are looking for. So, but for now, I think we are running out of time. So, yeah, we hope to see you again in our next bridge webinar. Thank you so much.
Okay, thanks to everyone.
All right.
Yeah, have a good day. Bye-bye.